Hello viewers, this is Sarita Umesh. Welcome to my channel Fun Chemistry. Today I will be teaching you the topic D-block elements or transition elements from the chapter Classification of Elements and Periodicity in Properties. The elements of group 3 to 12 are called transition metals. What is the reason? Because they show a gradual change or transition from metallic character to non-metallic character. If you check the electronic configuration, you can see their last electron is going to the D subshell. That's why we call them as D-block elements. So group 3 to group 12 elements are called D-block elements. Now we studied the general configuration of S-block elements, that was NS 1 to 2. Now the question is, what is the general configuration of D-block elements? You can see here it is N-1D 1 to 10 NS 0 to 2. What is the meaning of N? N is the outermost shell. In the outermost shell, there is a S subshell, and in the case of D-block elements, the number of electrons can vary from 0 to 2. That means sometimes there will not be any electrons. Most of the cases either 1 will be there or 2 electrons will be there. Now you can see N-1. Suppose your N value is 4. That means your shell is the L shell. So what will be N-1 shell? The third shell, that is M shell. In the M shell or the third shell, D 1 to 10. That means the number of electrons present in the D orbital can vary from 1 to 10. You have studied this in your second chapter, so I don't want to go in detail about the electronic configuration. You can try scandium to zinc. You can just write the electronic configuration and check. That we have done in the previous classes. Now, they form colored complexes. So the question, what is that? Cu2+. You know that copper can exist in two oxidation states. One is Cu+, we call it as cuprous, and the other one is Cu2+, it is cupric. Now, Cu2+, you know that copper sulfate solution. Copper sulfate solution means CuSO4. Copper sulfate is CuSO4. SO4 means it is -2, and copper, its valency is +2. So I am taking copper sulfate solution here, an aqueous solution of copper sulfate. Then it's treated with ammonia solution. You will get this particular complex. Look here, what is its color? Deep blue color complex. It's a beautiful color, beautiful blue. Okay, so transition elements or D-block elements can form complexes. Most of the complexes have characteristic colors. The next point is, most of the D-block elements show paramagnetism. What is paramagnetic substances? The substances that have at least one unpaired electron are called paramagnetic substances. And what is the effect of that unpaired electron? These kind of substances, if you keep in a magnetic field, they will be weakly attracted by the magnetic field. And the phenomenon is called paramagnetism. The next point, they form alloys. What are alloys? Alloys are solid-solid solutions. Alloys are solid-solid solutions, meaning the solute as well as the solvent are in solid state. So here you can see very important two alloys I have mentioned. One is bronze, the other one is brass. So bronze is an alloy of copper and tin. Sn means tin. Brass, copper and zinc. In these two cases, you can see copper I have written first, meaning copper is found in larger amount, meaning copper is the solvent and these two are considered as respective solutes. Coming back to the general electronic configuration, I forgot to discuss one point with you. That is, I told nth shell, that is the last shell, we call it as valence shell. But this term you should know. The second last shell, if this is the fourth shell, this will be third shell, 4s and 3d. So the second last shell is called penultimate shell. It's called penultimate shell. Suppose here you have n-2. n-2 means it is called anti-penultimate shell. The next point about D-block elements. Some of the D-block elements show catalytic properties. So the question, what is this catalytic properties? Meaning, some of the D-block elements can act as a catalyst. So you know that catalysts are substances which will increase the rate of a chemical reaction. Example, iron. We can use iron in Haber process. What is Haber process? Manufacture of ammonia from N2 and H2. Nitrogen gas and hydrogen gas is called Haber process. In that case, Fe is used as a catalyst. Then V2O5 called vanadium pentoxide. Vanadium is a D-block element and vanadium pentoxide is used in contact process. Contact process is the manufacture of sulfuric acid. Next point, they form both ionic and covalent compounds. You know what are ionic compounds, what are covalent compounds. Then they show variable oxidation state. The term variable oxidation state may be new to you. Now I have taken here one example, manganese. Last class or the last chapter we studied the same thing, the electronic configuration of Mn25, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d5. The last electron is going to the 3d subshell. So now you must have understood. This is the n-1 d orbital. This is the ns orbital. Now I have drawn here a box diagram. So up to 3p6, if you count, it will be 18 electrons. So I am taken it as argon. Now for us, there are 2 electrons. You can see here with a half spin, anti-parallel spin. One is plus half means other will be minus half. You know the spin quantum number. Then 5 electrons are there in d orbitals. They are equally distributed in the d5 d orbitals. This is as per Hund's rule. We studied that in the second chapter. Now, Mn2 plus. What is the meaning of Mn2 plus? From the last shell. Last shell is 4th shell, not 3D, 4th shell. That means 4s subshell, 2 electrons gone. So, what is the electronic configuration? Argon 3d5. Argon 3d5, d orbital is half filled. D orbital is half filled. You know the importance of half-filled d orbitals. Half-filled d orbital is highly stable. Mn4 plus. What is the meaning of Mn4 plus? 2 electrons from 4s and 2 electrons from 3d has removed. Now only 3 electrons are there in 3d. That's why argon 3d3. Now Mn7 plus. What is the meaning? It can lose all these 5 electrons and these 2 electrons. So total 7 electrons lost from this. Understand one thing? First the electron will go from here, then remaining will go from this. So these 2 plus these 5, total 7 electrons lost. So Mn7 plus. In potassium permanganate, you know, KMnO4, KMnO4. Oxygen is -2. 4 oxygen means it will be -8. Then potassium, you know, it's a first group element. Its valency is +1. It's not going to show any variable oxidation states or valency. So this is -8. This is plus 1. So if you subtract, you will get minus 7. To nullify the charge, you need here plus 7. So the oxidation state of Mn in potassium permanganate is plus 7. So here you can see Mn 7 plus argon. The configuration become argon's configuration. Very stable. What is the reason? The most stable ion of Mn is Mn7 plus because it reached a noble gas configuration, that of argon. Then next points are very easy. Generally they are hard and high melting metals. We normally call them as heavy metals. So they are good conductors of heat and electricity. Then already this point I have discussed. They act as a bridge between metals and non-metals, or a highly reactive metal and a low reactive metal. Then this is the 3 different series of D block elements. We have 3 different series in the case of D block elements. What are they? 3D series, 4D series, 5D series, meaning in this case, that is scandium to zinc, the last electron will be going to the 3D subshell. Then 4D series, that's the second series, that is from yttrium to cadmium. The last electron will be going to the 4D subshell. Then 5D series, or the third series of transition metals, that is lanthanum to mercury. Lanthanum to mercury. Here the last electron will be going to the 5D subshell. Hope this much is clear. In detail, I have given you a video about D block elements.